Good morning, dear students. Myself, Dr. Hari Priya, working as Associate Professor in Chemistry, Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. In today's class, we are going to discuss about external treatment of hot water, which includes ion exchange process. Ion exchange process, or we will call it as demineralization of hot water. Demineralization of hot water. So in today's class, we are going to discuss about ion exchange process. It is an example for external treatment of hot water. We will call that one as demineralization of hot water also. And one more topic, that is desalination of brackish water. Desalination of brackish water. Let us start with the first one, that is ion exchange process or demineralization of hot water. So this process, it is meant for external treatment of hot water. So hot water, if it is subjected to purification by using this ion exchange process, what kind of mechanism it will follow up and what will be the result. Those kind of things we will come across with this ion exchange process or demineralization of hot water. So for this process to take place, we have to make use of resins as membranes. Resins as membranes. So what are resins? Resins can be defined as insoluble cross-linked organic long chain polymers which are having porous structure, which are having micro porous structure. What do you mean by porous structure? Just like sponge. Sponge is a kind of material. Whenever it is dipped in water, in a dish or bowl of water, it is able to absorb that water content. That is what we call it as porous structure. It is having very small diameter or small pores that were present in the material. That's why it is called microporous structure. Resins are defined as insoluble cross-linked organic polymers which are having microporous structure. Cross-linked means these are having 3D network. That means 3-dimensional network. Along X, Y and Z axis, they are having interlinking. If you notice that a long chain or polymer backbone of these kind of resin polymers, so 3-dimensional network they will have. That means along X, Y and Z axis they are interlinked. That's why resins can be defined as insoluble cross-linked long chain organic polymers which are having microporous structure. So in this ion exchange process or demineralization of hot water process, we are going to make use of two different types of resins. What are they? Let us see. One is cation exchange resin and the other one is anion exchange resin. That means in this process, if you check the apparatus, it will have two different compartments. One is cation exchanger and the other one is anion exchanger. The cation exchanger, it is provided with cation exchange resins and the anion exchanger, it is provided with anion exchange resins. Let us see what are these two. Cation exchange resins are defined as the resins which are capable of exchanging their H plus ions, that is cations, with cations present in the hot water. The resins which are capable of exchanging their H plus ions with cations of hot water. Cations present in the hot water. What type of cations are present in the hot water? We know that calcium and magnesium ions are present as cations in the hot water. That means whenever hot water is allowed to pass into this cation exchanger, which is fitted with this cation exchange resin, it is capable of exchanging its H plus ions with the cations that were present in the hot water sample. That means H plus ion, it is mutually exchanging with calcium and magnesium ions present in the hot water sample. So such kind of resins are called cation exchange resins. So for this, I am going to consider the example of styrene divinyl benzene, copolymer of styrene divinyl benzene. So I am going to consider styrene, vinyl group that is attached to phenyl ring. Here so this is copolymer of styrene divinyl benzene. If it is subjected to sulfonation or carboxylation, say for example, I am considering SO3H here. If it is subjected to sulfonation, we will get SO3H. In this, SO3 will carry a minus charge and H will carry a positive charge. So this is an example for cation exchange resin, which is named as copolymer of styrene divinyl benzene, which is subjected to sulfonation. When this is made in the form of a membrane, this is made in the form of a membrane and fixed as a bed in cation exchanger, then this compound is having H plus ions in it. So this is capable of exchanging calcium and magnesium ions that were present in the hot water. So examples for this type, commercially we will call them as Dovex 50, Amberlite IR 120. So these are examples for cation exchange resins. So let us go with what are anion exchange resins. These are the resins which are capable of exchanging their OH minus ions. The resins which will contain OH minus ions, and they are capable of exchanging their OH minus ions with the anions that were present in the hot water. What type of anions are present in the hot water? We know that chloride ion, SO4, 2 minus ion, these were present as anions present in the hot water. So these will be mutually exchanged with OH minus ions that were present in the anion exchange bed. So example for this one, copolymer of styrene divinyl benzene, which is having quaternary ammonium group. That means this is copolymer of styrene divinyl benzene, which is having a quaternary ammonium group, right? So here I am making use of quaternary ammonium group. Actually valency of nitrogen it is 3. If it is having more than 3 bonds like this, it will get a positive charge. This is called quaternary ammonium ion. So if that is taken, this quaternary ammonium salt it is taken, then it is on treatment with NaOH, it will acquire a OH minus ion there. It will contain OH minus ion due to treatment with NaOH. So if this is taken in the place of anion exchanger, then it is able to exchange its OH minus ions with anions that were present in the hot water. We know that Cl minus and then SO4 minus 2 are the anions that were present in the hot water. So whenever this is made as bed or membrane in anion exchanger, it is able to replace its OH minus ions with the anions present in the hot water. So these are called anion exchange resins. So let us go with the process. As I told you, it is an example for anion exchange process or demineralization of water. It is also an example for demineralization of water. So let us see. So this is the apparatus that is used for the entire process, which will contain 2 compartments. One is called, that is number 1, it is called cation exchanger. 2 is called anion exchanger. So into cation exchanger, we are supposed to make cation exchanger as a bed. So in the previous slide, we explained about cation exchanger bed and anion exchanger bed. So in that, cation exchanger means which is having or which is capable of exchanging its H plus ions. So I am going to consider cation exchanger resin, that means RH. That entire long chain of organic compound is represented like R. At the end, it is carrying H plus ions. This is important for us because it is meant for exchanging during the process. That's why in short form we will write like RH. If the entire thing we will write in the mechanism part, it will become very difficult. So it will be minimized by representing in a simple way, that is RH. So this RH, it is made as cation exchanger bed in cation exchanger, that is part 1. So this is cation exchanger. So as this is the inlet provided for allowing the passage of hot water. So if it is once entering into this one, immediately this RH that is present, what it will do? RH. In the water we are having, say for example, calcium and magnesium ions, right? RH, 2 moles we have to consider. Simply, when hard water is allowed to pass into this one, this bed it is having RH, that is cation exchange resin, which is capable of exchanging its H plus ions, right? So it will convert into R2Ca. Along with that, the 2 moles of H plus will be released. So this is the reaction that is taking place, first reaction. And after that, along with this, if it is having magnesium salts, same RH is able to exchange its H plus ion with the magnesium ions, thereby converting into R2Mg. Along with that, 2 moles of H plus will be released. So these are the reactions that were taking place when hard water is allowed to pass into the first cation exchange chamber. So after this R2Mg and R2Ca formation is taking place, then H plus ions will be produced. These are allowed to pump into second compartment where you are having anion exchanger. Second compartment name is anion exchanger, where we are having anion exchange resin. So as I told you, entire long chain of organic polymer is simplified and represented like R, and moreover it is capable of exchanging OH minus ion. Simply we will represent that anion exchange resin as ROH. Okay. So if you notice the reactions, ROH. So these are cation reactions or cation exchange reactions. These are anion exchange reactions. So ROH is able to change, that is mutual exchange, its OH minus ions with the Cl minus ions that were present in the water sample, and as a result it is able to release OH minus ion. And if it is like sulfate, 2 moles of OH we have to consider, and if it is of sulfate ion, it is able to exchange with its 2 OH minus ions. So you will get R2SO4 plus 2 moles of OH minus ions. So from cation exchanger we are getting H plus ions. From anion exchanger we are getting OH minus ions. So if you notice the net reaction, H plus OH minus gives rise to H2O. So at the end of the purification, H plus ions from the first compartment, that is cation exchanger, and OH minus ions from the second compartment, that is anion exchanger, will combine together to produce water molecules. That's why it is named as demineralization of water sample. That means we are going to remove the minerals that were present in the hard water sample. So it is also known as demineralization of hard water. So these are the reactions that were taking place as a part of mechanism during ion exchange process. I am repeating. First we have to allow the passage of hard water into cation exchanger bed. There we are having cation exchange resin, which is represented like RH. It is capable of exchanging its H plus ions with the calcium ions present, thereby producing 2 H plus ions. Then this water it is forcibly pumped into second part, that is second compartment, that is anion exchange bed. There what will happen? It is having ROH, cation exchange resin, that is represented like ROH. It is capable of exchanging its OH minus ions with Cl minus ion and thereby releasing OH minus ions. So these are the reactions that were taking place. So if continuously, if this exchange ion exchange process, it is continuously taking place for 8 to 10 hours, these resins they get exhausted, which were acting like membranes in the containers. So for the regeneration, we have to make use of 2 chemicals. For regenerating cation exchanger, that is RH, we have to make use of dilute HCl or dilute H2SO4. So it is to be stored in this regeneration tank, and then it is injected into this cation exchange bed. There it is able to combine with washings that were present in this tank, thereby again regenerating that cation exchange resin. If I want to regenerate anion exchange resin, then I have to make use of dilute NaOH or KOH, which is able to regenerate anion exchange bed. So let us go with the mechanism or reaction part. So far what I have discussed, let us see once. So as I told you, what happens in cation exchange reactions? It will contain cation exchange resin RH. When added to hot water in the first compartment, it is capable of exchanging its H plus ions with the calcium ions, thereby releasing H plus ions into the water. So in the next, it is allowed to pass into the anion exchange chamber. There, it is able to exchange its OH minus ions with the Cl minus ions or sulfate ions, thereby releasing OH minus ions into the hot water. So at the end, what will happen? H plus and OH minus will combine to produce water molecule. So these are the reactions that were happening. And what happens during regeneration? So if you notice the regeneration reactions, as I told you, we can generate cation exchange resin by passing dilute HCl or dilute sulfuric acid solution into the regeneration chamber and then injected into the cation exchanger. So this is the, if you notice, this is the corresponding reaction that is happening. So, and the washings we have R2Ca. In the previous reactions, if you notice, I am adding dilute HCl. This will dissociate to H plus and Cl minus ion. Okay. So, this H plus ions of 2 moles combine with this R2Ca. As a result, they will convert into cation exchange resin, that is RH. That means RH, it is again regenerated and then producing finally calcium ions. These will be removed. These will be removed from the outlets that were provided at the bottom of each tank, cation exchange tank and anion exchange tank. So if you notice anion resin regeneration, so this is meant for regenerating anions, that is ROH. So for this we have to add NaOH, dilute NaOH or KOH. So it is able to release its OH minus ions, and in the washings we have R2SO4 combined with that, thereby producing 2 ROH, that is anion exchange resin. It is regenerated and then sulfate ion it is also obtained, which is allowed to pass into outlet and then it is taken out periodically. So these are the reactions, the mechanism that is going to take place. So next we are going to discuss about desalination of brackish water. So what do you mean by brackish water? Brackish water means the water which is having content of salt in dissolved state. Salts, if they were present in dissolved state in water, we will call it as brackish water. Generally, we will call seawater as an example for brackish water because it will contain greater than 3.5% of salts that were present in dissolved state, especially NaCl. NaCl, it is present more than 3.5% in seawater. So this is an example for brackish water. Likewise, if dissolved salt content is greater than 3.5% in water sample, then we will call that water sample as brackish water. I just want to remove the salt content from brackish water. That means the process of removing dissolved salt content from water is what we call it as a desalination of brackish water. So it is called desalination of brackish water. So water that is containing high concentration of dissolved salts with peculiar salty or brackish taste is what we call it as brackish water, as I explained just now. And it should be present, that means amount of salt content that is present in dissolved state should be greater than 3.5%. So generally we use different methods. Here 3 were listed. 3 different methods were listed in which reverse osmosis is there in our syllabus part. So let us see. So 3 were listed here. Generally used or commonly used methods for desalination of brackish water are reverse osmosis method. So by subjecting that hot water to change in pressure conditions, that means applying pressure in reverse direction, it is able to arrest all the dissolved salt content and allows the passage of solvent molecules to the other side. So this is what we call it as reverse osmosis. And the other one, it is electrodialysis, in which the basic principle of electrolysis will be applied. That means the process in which if you supply electrical energy, then it is able to convert into chemical energy. So in using this principle and knowing the basic knowledge that as applying electrical energy, anions always move towards the anode and cations always move towards cathode. This electrodialysis will take place. Okay, that's why it is called electrical or we can say electrodialysis method. And last one, it is thermal distillation. That means purification of water. It is done by subjecting to some amount of temperature. So these are the three methods generally or commonly we will use. Let us go with the reverse osmosis method, which we are having in the syllabus. So before going to the actual reverse osmosis process, we should have an idea about osmosis. What do you mean by osmosis? Osmosis means when two solutions of varying concentrations are available and they are separated by a semi-permeable membrane. If they are separated by a semi-permeable membrane, then if you supply pressure on dilute side, then the passage of solvent molecules will take place from dilute side to concentrated side. That means if I supply some amount of pressure on dilute side, then what will happen? This semi-permeable membrane allows the passage of solvent molecules. Solvent molecules means water molecules. Because we are using hard water. Water, it is solvent, and salts present in dissolved state will act like a solute. So this membrane is able to allow the passage of solvent molecules from dilute side to the concentrated side. So this process is what we call it as osmosis, and the pressure we are applying is what we call it as osmotic pressure. That pressure, it is named as osmotic pressure. Now using this principle, if I do some kind of changes, that means if I supply pressure in excess, that means hydrostatic pressure in excess to this osmotic pressure, let it be like 15 to 40 kilograms per centimeter square. On reverse side, that means initially we supplied in dilute side pressure, now we are going to supply on concentrated side. If I supply this hydrostatic pressure in excess to the osmotic pressure, that is in a range of 15 to 40 kilograms per centimeter square on the concentrated side, then what will happen? Because of this process, solvent molecules are forced to move from concentrated side to the dilute side along the membrane. What this membrane will do, which allows the passage of solvent molecules from concentrated side to dilute side. That means reverse principle it is applied. That's why it is called reverse osmosis. It is known as reverse osmosis. When two solutions of unequal concentrations are separated by a semi-permeable membrane, then if you supply some hydrostatic pressure in excess to the osmotic pressure, that is in 15 to 40 kilograms per centimeter square on concentrated side, then the movement of solvent molecules will take place from concentrated side to dilute side. So this is what we call it as a reverse osmosis. So this is also known as we are using membrane filtration technique, it is also known as superfiltration or hyperfiltration. As I told you, this principle is known as reverse osmosis principle. And in the place of membrane, we will make use of cellulose acetate, and nowadays the cellulose acetate, it is replaced with the polymer materials like polymer methacrylate and then polyamide. So if you notice this application of principle, so here this figure reveals that this is water, that is hard water we have considered, that's why it is mentioned like salt water, right? And this is the membrane which is made up of cellulose acetate. Then we are going to apply hydrostatic pressure on concentrated side, that means salt water side. Initially it is considered to be the concentrated side, means it will have salt content. This is the membrane, and this is the salt water content, that is called concentrated side. On the same side, I am going to apply hydrostatic pressure in excess to the osmotic pressure, that is from 15 to 40 kilograms per centimeter square. Then immediately what will happen? On concentrated side, we are applying pressure. Then membrane itself allows the passage of solvent molecules, that is water molecules, to the dilute side. And that is what we call it as all that salt content will stay back in the concentrated side, and the solvent molecules like water, that is H2O, will move towards dilute side. So this is about the RO process or RO method. I am explaining again. If pressure is applied on the concentrated side, that means it is the concentrated side means salt water which is having dissolved salts of calcium and magnesium, and then if we supply hydrostatic pressure in excess on this concentrated side, then this membrane, semi-permeable membrane, allows the passage of a solvent molecules, that is water molecules, to the dilute side. That means all the salts they get arrested in the concentrated side, and water which is free from salts is allowed to flow into the dilute side. This is what we call it as RO principle. In today's class, we discussed about two topics. One is external treatment of hard water, in which we discussed about ion exchange process, how this process will be carried out, what is its introduction, and what it will contain: resins, cation and anion exchange resins. Anion exchange resins, their definition, examples, and then brief explanation about a process involved in ion exchange or demineralization of hot water, and what are the reactions that will be taking place during the mechanism part, and after that how regeneration will take place, and the mechanism part related to regeneration reactions also discussed. And next we went to desalination of brackish water, in which we discussed about RO method, what is the principle involved in RO method, and how that process will take place. And coming to this RO method applications part, in day-to-day life, in domestic purpose, generally we use water purifiers for getting mineral water. In that this RO principle it is applicable. RO principle it is applicable. That's all for today's class. In the coming session, we are going to discuss about batteries chemistry and corrosion. That means so far we completed unit 1, that is water and its treatment. In the coming session, I am going to explain about start about unit 2, that is batteries chemistry and corrosion. That's all for today's class. Thank you very much.